Hello, everyone. My name is Anjum Javed, and I'm just completing my research with LJMU for my master's in artificial intelligence and machine learning. And today I'm here to be presenting for my final thesis. So without further ado, let me get started off with the presentation. The topic of my research is auto-detection of hate speech and multimodal memes using deep learning and attention-based models. And I'll talk about how the whole research shaped up and what was my contribution in this. This is a brief agenda of what I'm going to be talking about in the next few minutes. So what was really the motivation and the background to be taking such a topic? So let me just introduce you to what the topic is about and why the need is felt more than ever before to curb this menace, this societal concern, which is growing at a staggering pace. As we all know, memes are generated, the content, the multimodal content is getting generated at an ever increasing pace on all social media platforms. And memes, the combination of image and text, when it comes together, it is used to convey humor, jokes sometimes, but it is also increasingly used as a vehicle to propagate hate speech. And it has been observed that hate speech originating from social media platforms often leads to people committing hate crimes in public, and there is statistics to speak to that. So that is the motivation to try to use technology to address this issue for social good. Then hate speech becomes a challenging problem to solve because it is much more complex than a visual question answering or a natural language for visual representation or image captioning, where it is very evident looking at the image and the image that what is being done in the image and then try to understand it in natural language. So today, the capability, there is capability in the machines to be able to extract feature from images and understand what is happening. I'm talking about these large CNN based models and which can extract features and help detect what are the features in the image and help identify the objects. But hate speech is even more complex and challenging a problem to solve because it requires understanding of the image and the text and the word knowledge. Combining all three, there has to be cross-modal relationships which have to be well understood before it can be determined that the content is hateful or not. So that makes it a very challenging problem to solve, for a machine to solve, so to speak. Current state of the art is definitely much below par of the human accuracy levels, as can be seen. And obviously, if you want to attend to this problem by using deep learning based models, because that is the obvious choice that we have if you want to detect hate speech at scale on the social media platforms and try to nip it in the bud, try to quarantine such content while we are in our sleep. There should be an AI bot somewhere which should tell that, there is a hate content which is being posted and you should be doing something about it. So, so this is the main motivation behind the study. A brief definition of what hate speech is. Why it matters now more than ever before is, and the statistics has to speak for itself. This is very evident that now hate speech is growing, and hate crimes are being committed in the societies, and the hate speech originating from the online social media platforms is a big contributing factor to that. And these are some of the statistics that has to speak to it. You never know when it can strike you. Being you is not a crime, but targeting you is. So hate speech is definitely being looked at very seriously, and laws and policies have to be framed around it by the jurisdictions, by the countries, by by the various law enforcement agencies coming together. And it has to be a concerted effort between industry, academia, and the governments to address this growing societal concern. This is some of the glimpses of what is happening world over to how it is being looked at the world over, and why it is such a serious concern. I'll talk about the entire thesis work and how I went about solving for some of the research questions that I had with the study. I conducted a thorough literature review for my thesis, and while I was doing the literature review, I understood that the state of the art for hate speech has come a long way, right from identifying hate content in text uh, to identifying hate content unimodally in images or text, and now to be able to understand um, hate speech in multimodal memes, which are images with the text embedded in it, and where the relationship between the text and the image is not so obvious for determination of the hate speech. So attention-based transformer models are being used to extract the image features, to extract the text features, fuse them, pass through the transformer layers with self-attention, and then try to classify if a meme is hateful or not. And the architectures in that area are getting better and better. The integration of world knowledge, I was talking about the third dimension, image, text, and then the world knowledge. The world knowledge integration is also something that is an ongoing pursuit in the research studies. And of course, this problem is getting attended both on the data side as well as on the model side. So while the model architectures are getting better and better, the need is also to have more holistic benchmark data sets. Because right now, and what I've used for my research also is a limited data set, which is created for a challenge, hateful meme competition by Facebook AI research. So that is just very minimalistic data set, right? It's not a huge corpora of hateful meme data set, which is representational of hate content, which is getting generated across the platforms worldwide. It is just a very small data set. So now the need is felt more than ever before to have large holistic benchmark data sets, which does not have any annotator bias, because that can also have a bearing on how your models are getting trained, and then their predictions later on. We identified that during the course of the study that the single stream encoded multimodal models, which are the ones where there is a single stream, the vision and the language are fused, the features are fused, and then they are passed through a single transformer layer. While in the dual stream, there are two different layers, two different transformer layers for attending to image and the text features, and then they are fused towards the end, and a weighted averaging is done to come up with a score, probabilistic score, whether a meme is hateful or not. So we have observed in the study that the single stream encoded transformer models perform better than the dual stream transformer models for hate speech detection. The single stream transformer model that I experimented with is VisualBird and Oscar. VisualBird uh, uh, tries to identify the relationship between the image and the text, while Oscar adds a third dimension to it in terms of identifying the object tags within the region proposals or the regions of interest. So that third dimension, which it adds in the feature space, acts like a soft label, and it enhances the feature representation. These are some of the research questions that you're trying to solve for in the study. Fusion of image and text, whether it has any tangible advantage to better detect hate speech is what we are trying to see. And if it is any better over the unimodal models or the multimodal or image-only unimodal models or text-only unimodal models, why a multimodal model is needed with so many parameters to be trained. Then we are also trying to see whether better object detection techniques with image and language modeling during the feature extraction stage, can it help identify better features for bettering the accuracy and AUC ROC of the model for hate speech detection. These are the two evaluation metrics that we're using, and I will talk about it in a bit, why we are using these metrics for the study. And does the number of features extracted by the object detection frameworks, does it improve the accuracy of the model? So whether 100 bounding boxes or 200 bounding boxes, whether the feature extraction from these many bounding boxes, or more number of bounding boxes, helps in improving the accuracy of models at inference time. And then trying to see if transfer learning with pre-trained multimodal models helps in better fine-tuning of the models for the downstream hate speech detection tasks and help them converge faster, right? So we're saying that we're using large-scale data sets for pre-training, large-scale image caption data sets like conceptual captions and common objects in context, which are large image caption paired data sets. And the VisualBird model is already trained on those. And then you're trying to fine-tune it to the hateful meme data set, which is about 10,000 memes that we are trying to train it for. And then try to adjust the visual linguistic embeddings, aligning better to the detection of hate speech. So those are the research questions that we are trying to address. These are the data sets that we have used. Hateful meme data set for phase 2 of the competition, which was released by Facebook AI Research, and the Memotion data set. And then we used faster RCNN and detectron-based framework using mask RCNN for feature extraction using a ResNet 152 or a ResNet 101 backbone architectures. 100 and 200 bounding boxes is what I've tried for region-based feature extraction with the Visual BERT and Wilbert models. Wilbert is of course dual stream, and Visual BERT is single stream. Then we tried to use the pre-trained models from the MMF framework and the Vilio framework. The Visual BERT, Wilbert, MMBT region, MMF transformer are all used from the MMF framework, and Oscar is used from the Vilio framework. And then what I'm trying to also do in this research is see if we can better the performance of the models on the accuracy and the AUC ROC metric by creating an ensemble of models. So if there is a Visual BERT, which is the best model from the Visual BERT, the best from Oscar, having complementary capabilities or add-on capabilities, if they are combined, right, can I get some synergies out of it? Is what I'm trying to see with this study, and also see, if the ensembles are helping to increase the performance of the models. These are some of the hateful memes which were identified by the model. I'll come to it in a bit, but let me just talk through the methodology that was followed. And this is the overall methodology, the data set. It all we didn't. I did not do any class imbalance, addressing because it's little imbalanced, the data set, but that is fine, and that is why I'm using the AUC ROC metric to identify and its recognizability or predictability on the hateful memes and the non-hateful memes. So I'm not using any class balancing technique or addressing class imbalance in this. I'm not using any data augmentation either. The data set has a sufficient number of image and text confounded examples for training the models for true multimodal reasoning. Yes, there is an image, there is text, there is feature extraction from the image, there is feature extraction from the text. Text is, so I didn't have to do any OCRing on the text. So the text is already provided in the JSON files, and it's taken from there. And then the text encoding is done using the BERT model. The image feature extraction is done using faster RCNN or mask RCNN. And then the features are fused. And then it is further taken through the transformer test, whether you're trying to train it with Visual BERT or Wilbert or an Oscar. It's all a black box. These are pre-trained models which are fine-tuned. Visual BERT is pre-trained and then fine-tuned. Wilbert is pre-trained and then fine-tuned, pre-trained on conceptual captions or COCO. Those are the two pre-training datasets that I've used. Oscar is task-specific pre-trained using hateful meme dataset, and Oscar, while the Visual BERT and Wilbert tend to use brute force methods to understand the image text relationship, Oscar, as I said, that it also adds the object tags along with the image and the text embeddings. That helps to understand the semantic relationship better between the image and the objects in the image and the text for hateful meme detection, right? So these are some of the ensembles I've tried, and then hyperparameter tuning is performed. These are some of the results that I observed during the course of the study. Found that Visual BERT COCO pre-trained and then fine-tuned performs really well over the unimodal models, as can be seen both in terms of accuracy and AUC ROC. The VisualBird Coco ensemble, I'll come to it in a bit, why I could not do extensive hyperparameter tuning, and that is because of the limitations of the GPU and the RAM. With Google Colab Pro Plus, which I was using for experimentation work. But still, basis some settings that I could identify from the prior research work, I did some ad hoc hyperparameter tuning and identified the hyperparameter values and tried to create an ensemble of VisualBird Coco models, which indeed helped it get better from the VisualBird Coco individual model. Had I been able to do an extensive hyperparameter tuning using more sweeps, more values, a grid search, detail one, I would have been able to identify more optimal hyperparameters, and this figure would have indeed gone up. But what I'm trying to establish is whether an Oscar added to a VisualBird, right, an ensemble of that, and I've used simple averaging for ensemble predictions, whether an Oscar combined with VisualBird Coco ensemble, whether it helps get better in performance. And as you can see that indeed AUC ROC increased a tad bit. This could have been more if I would have tried with more optimal hyperparameters given the GPU and the RAM requirements were met. Then I was also able to establish that the single stream encoded multimodal models perform better than dual stream multimodal models, as can be seen here. Both are conceptual captions pre-trained, and you can see that VisualBird pre-trained on conceptual captions and then fine-tuned on the hateful meme dataset performs better on both AUC and accuracy metric. And these are some of the visualizations that I observed during my experimentation to substantiate the claim in the previous slide. As I had mentioned that the experimentations were a little limiting in terms of hyperparameter tuning and finding out the most optimal hyperparameters. Nevertheless, I tried with a number of different hyperparameters to try different optimizers, primarily experimented with Adam optimizer, binary cross entropy loss, focal loss, and then learning. I experimented with various combinations of learning rate ratio, warm up. Then all these different settings, the batch size which I tried, I kept it at 32, so I could only experiment with a batch size of 16 or 32. While some of the studies do suggest trying with higher batch sizes and have observed a greater AUC ROC on the model individually. So with this study, I could not experiment with batch sizes higher than 32, like 64 or 80, because of the GPU and high RAM configurations which were required. In fact, the GPU, the NVIDIA GPU that I was rendered, and the RAM that was provided it was taking a long time to train the visual linguistic models on a large number of parameters. So the experimentations really were taking a long time. The models developed may not be able to generalize, detect hate from all various different platforms. While this is a intent to get better at hate speech detection and try to do it with machines, but the state of the art has to take it to the next level. So this is a natural limitation coming out of the whatever model is developed with this experimentation and research. Conclusions and discussion. Um, I would come to this slide in a bit, and I would just go back to one of the previous slides on the results. So when I say that 77%, 77.37% is the accuracy of the AUC ROC of the ensemble. That means 77% of the times it is able to identify a hateful meme and a non-hateful meme, right? So hateful meme data set, on the top, as you see, are the ones which the ensembles could correctly predict. Pred equal to 1 is hateful, pred equal to 0 is non-hateful, and it is able to correctly identify. And this is the real data. This is the real data set from the hateful meme data set that I used for the study, that the meme was able to predict, do the predictions on. This is from the unseen test data of the hateful meme data set. Then I also talked about the multimodal reasoning. And this is what the true multimodal reasoning means, right? So when I said that I didn't have to do any data augmentation or include more text confounded and image confounded examples, what it essentially means is that the hateful meme data set has a good balance of text confounded and image confounded samples. What that means essentially means is image confounding is when you change the image of the meme, text remaining the same, the meaning flips. It can change from hate to non-hate and otherwise. And text confounded is when meme remaining the same, you change the text, then the meanings can change. You can see that in this slide very well. And what we are trying to develop with this study is true multimodal reasoning. You're not relying on any unimodal priors in the text or the image. We are saying that the model should be able to make sense looking at both image and text features and then be able to take a call whether a meme is hateful or not. And yes, this is an ensemble of model that we are trying to develop and trying to leverage on the strengths of both VisualBird and Oscar to create an ensemble of model and then predict on hateful memes. What do we get out of this study? Auto detection of hateful memes, and deep learning and attention-based models which can then screen, auto detect, and quarantine hateful meme at scale, right? 100% AI-based auditability on hateful memes on social media platforms. Because it's a huge task if somebody is looking at each and every meme which is getting generated there on the online social media. Versus if you give the task to machine, it can screen each and every meme and identify if there is any iota of hate content in that. So that makes that helps with compliance, that helps with creating a just and a fair democratic setup. It is also an aid for the auditor and the content quality team and content moderation. The straight through cases can be quarantined easily, while the ones where the model doesn't have a very high score, a confidence score, can be highlighted, and then there can be a human feedback loop saying that this was identified as hateful by the machine, because there can always be a false positive or a false negative, which we are trying to balance. So they can always be a false positive, false negative, which cannot which cannot come down to zero. There will be such instances where the machine has wrongly identified a hateful meme as non-hateful or otherwise, and then there is a human feedback loop which corrects it, and then the model goes for retraining. So this is what we what we get out of this when we look at the industry use of it. Some of the conclusions to this study. The experiments conducted in this study, they show that visual cues are definitely very important, sometimes more important than the linguistic ones for determining hate speech in multimodal memes. Ensemble of multimodal models helps in bettering the performance, though not always. And extensive ablation studies does need to be conducted to substantiate that. But in general, it has been seen that an ensemble of models, different models, have a positive effect on hateful meme detection and bettering the performance score. The single stream models outperform the dual stream model. And that is what we have seen in the study. The visual BERT model outperforming the Wilbert model on hate speech detection tasks, with different feature extraction techniques being used. And the best predictive model still shows an AUC ROC of 77%, which is much below the human accuracy levels currently. The gap in human benchmarks and a best performing multimodal model framework shows that there's a lot of scope for research in this area, and the research itself goes beyond understanding image and text alone. There is additional context beyond visual and textual features in terms of the world knowledge, worldview, that has to be understood and infused into the feature space to better understand the hate connotations. Some of the contributions that I could make with the study. So this study identified that it is possible to try different ensembles, or an ensemble of ensembles, as I would say. You have an ensemble model, and then there is another ensemble model, and try to ensemble them, and then see what are the complementary visual linguistic capabilities can bring to bear to get better at hate speech detection in multimodal memes. Then the study also identified that better feature extraction techniques upstream. I used Detectron, Mask RCNN, and Feature RCNN. In most cases, Detectron, Mask RCNN performed better. So it means better features matter more, not more features. So better features matter more in terms of better determining hate speech. And when these pre-trained models were fine-tuned on the downstream hate speech datasets, the better feature extraction techniques really helped. And this is one of its kind study, I would say, to combine models from both Vilio and MMF framework. While the researchers would sometimes research everything from within the same framework, but I've tried to use different settings from different frameworks, and then trying to combine the results. And these are some of the contributions. It always helps when try to take model which is trained on different data sets. I've used hateful meme data set. I've also use a subset of Memotion data set, and that is another thing that I observed, that combining hateful meme and Memotion data sets helps get better at performance than using just hateful meme dataset alone. So training models on different hateful meme datasets and then bringing back them together in an ensemble can really help better the performance of the models and the generalizability of the models. Some of the future work recommendations: integration of adaptive knowledge on world events, right, for better understanding of cross-modal relationship. I've talked about it. This is an ongoing area of research. Integration of meme metadata and scene understanding. And due to the GPU and the RAM size limitations I talked about, integration of meme metadata like race, gender, entity, emotion, scene understanding using scene graph parsing for models like Ernie-Will, which are again provided in the value framework. I wanted to study with all of them, an ensemble of a larger number of models, um, and use some weighted averaging, simple averaging or rank averaging to create an ensemble, which I couldn't. But this is a future work recommendation to bring um, meme metadata understanding, scene understanding uh, into the feature space, along with the object tags, of course, uh, to try to see if the performance of the model gets better, rather than just using brute force methods to extract the region features and then trying to understand the image text pairs and what is happening between them. Zero shot models, yes, we don't want a whole lot of fine tuning. We just want the pre-trained model and use it on the downstream task. So zero shot models, wherein the model is trained, you don't have a whole lot of data for training on the downstream task, but you still want the model to generalize on that task. That is where the zero shot model comes into picture. And we want zero shot models to be trained on these conceptual understanding of what hate is and what all possible combination of features create hate. DAL-E models have come off late, wherein you have text and then it can come up with an image. That's wherein it can really help these kind of techniques to create to help with the get better with the state of the art for hate speech detection, um, because the large benchmark data sets on hate speech missed, while it may still take some time and effort, we need to address this concern, and the models have to get better to be able to create these kind of data sets, understand the hate connotations, and then try to address it, because we may not get the data all the time, the real data all the time, but we have to actually be able to strike at the core of it and say that this is hate, and I understand. It's the machine speaking like that. And then, of course, increasing the performance of the hate speech identification by training with lesser number of parameters, because otherwise the model tends to be heavy. It leads to increasing the carbon footprint when the machines when the model is trained for a longer time, and then of course using quantization techniques to have better performance at inference time, have a smaller footprint of the model, and be able to generalize better. Um, a couple of other things which I have not mentioned here, while just talking about image, text, and trying to identify hate, and that hate can come from many different modalities. It can be in audio, video, and GIFs. So the future course of direction would be to identify hate speech in different multimodal models with different modalities, even beyond image and text alone. Then code mixed languages, trying to identify hate speech in them. So that is the next big frontier. And then, of course, we want explainability and interpretability in deep learning models for hate speech determination. That has to be there. It has to be baked into the systems. The BERT models, the deep learning models, are not so very good at being able to explain why the model took such a decision. But today it is very important to identify that if some content is identified as hate, then why the model took that decision, right? Um, these are some of the future work recommendations that I would say. And thanks a lot for the patient hearing for my final thesis presentation. And I hope to take this research work to the next level and contribute to the research community for a social cause. And thanks a lot. Thank you all.